So hello everyone, let us solve another LeetCode problem, and the problem name is n queens. So let us read the problem statement first. So the n queen puzzle is the problem of placing n queens on n cross n chessboard such that no two queens attack each other. Now you are given an integer n and you need to return all the distinct solution to this n queen puzzle, and you may return the answer in any order, and each solution should contain a distinct dashboard configuration of the n queens placement, where q and this particular dot both indicate queen. So q indicate queen and this dot indicate the empty space in that particular board configuration. Now we will understand this question with the help of this first example and try to find some solution out of it. But before that, we need to understand what does this particular thing mean, that no two queens should attack each other. So this simply means that, so let me just erase it and I'll explain that this particularly means that each and every row should have only one queen. So row should have only one queen. Each and every column should also have one queen, and all the diagonals like upper diagonal, lower diagonal, this kind of negative diagonals, also in these cases also there should be only one queen, because if there will be multiple queens, then those two queens can attack each other. So this simply means that at all the 8 directions, that is this up, down, right, left, and these particular positive and negative diagonals, in all the 8 directions we should contain only one queen at a time, otherwise they would attack each other. So we need to take care of this particular condition in order to place this all these coins. Now if you look at the constraints of the question, the constraints are very less. So this gives us the idea of using a backtracking solution, because we can try out all the possible scenarios by checking by placing queen at a particular place at particular position and then removing it and then placing it some other position. So let us see with the help of this first example and try to find some solution out of it. So this is the first example where n is given to us as 4, so that means that would be 4 cross 4 grid. So we need to place queens in this kind of configuration. Now we need to take care that each and every, like in all the 8 directions, we should only have one queen at a time, otherwise they would attack each other. So we will simply use a backtracking solution where we will place a particular queen at a particular position and then find whether this queen is at its correct position by doing recursion, and then in the backtracking part we will just remove that queen and try to place it at the other position. So let me just show you with this particular example. So initially the board will be empty, so we will have 4 kind of scenarios. Placing the queen at first position, will be placing the first queen at the first row. So in first row we will have 4 possibilities. Either we will be placing at the first column, second column, third column, or fourth column. If we place this queen at the first row, first column, then we need to now check at the second row. In the second row, which is this particular row, we will again have 4 options. Either we will put it in the first column, second column, third column, or fourth column, and so on and so forth. For all these particular scenarios we will have all the 4 possible cases for this one as well, and for this particular configuration also we will have the 4 possible scenarios, and this will keep on going. Once it will come back, it will try to remove this particular queen from here and place it in the second column, and for the second column we will do the entire process same. So for at the first row, second column, at second column the queen is placed, so we will try for the second row. Again in second row we will have 4 possible scenario: first column, second column, third column, and fourth column. Similarly it will again go on, and when it will backtrack we will remove we will try to remove this all this queen and have all the possible scenarios again. For we will check that in the recursion part. Then when it will come back to here, again we will try to remove this queen and place it at the other position. Similarly, this will happen for this one as well, and when it will come back here, we will again try to remove this and we will go on to the last configuration. So it will keep on going at each and every stage. Like it is here, so it will then try to remove this and it will go into this. It will then try to remove this. When it comes from recursion, it will try to put it here. So this will keep on going. So this is the kind of backtracking solution which we will use. So if you have watched my previous video, you will be easily able to understand this problem. So we will, this was the intuition behind this question: a basic backtrack, put the queen, solve recursively, then remove the queen, and this will keep on happening. So this is the basic idea of backtracking for this particular solution. So we will just like see the code now, and the code is pretty much the same. So we'll just directly jump onto the code now. So this is the code. So first of all, like what we are doing, we are initializing a vector of string, which is the final answer that we need to return, which will consist of all the kind of distinct configuration of this board, which is n cross n. Now we are initializing a board which will be the current configuration. So this will be current configuration. Then we will use the backtracking solution to solve this. So this answer and board we have already discussed, and this one is the nothing but the row which we are currently on. In the end, when we will find all the distinct solution, we will be returning the answer. Now what is there in the solve function? Let us see now. So in the solve function, there is the basic base case when the row is equal to board dot size. That means we have reached the end of the board. That means we have found a distinct configuration. So we need to push that into our final answer. So our current configuration will be pushed inside this answer, and then we will return. Otherwise, what will happen? We will iterate for a particular row by each and every column. So we have already seen in the drawing explanation, so that for row 1 we were trying all the 4 columns, for row 2 we were trying all the 4 columns. So this is the same. So for particular row we are trying all the columns. So it will go from 0 to board dot size, like less than board dot size, and it will check, is it safe to place queen at this particular position or not. Now let us see what is there in this is safe function. So this is the is safe function. So it is checking all the 8 possible directions which we have already discussed, that whether the queen is present in all the 8 directions or not for this particular queen. So let's say like we have a configuration kind of this. So let's say I have a put queen here, and initially I have a queen put here. I'm just taking a random example, so you don't need to worry much about that. So we will check for this particular queen whether it is right to place this queen in this particular row comma column or not. So for that we will check whether it is safe or not. So for that is safe function will be called. Now what will happen in this is safe function? So let me choose a different pen. So it will check all the 8 directions. So it will check upwards, downwards, rightwards, leftwards, left diagonal, right diagonals, like all the other diagonals as well. So it will check all the 8 directions whether it will find any queen in these 8 directions or not. If not, then it is the correct position for this queen to be placed. Otherwise, if we found any queen, that means we cannot put this queen at this position. So we need to try some different configuration. So we are checking this only. So we are first checking in the downward direction whether there is a queen or not. If there is a queen, that means this is not the safe place. So we will return false. Then we are checking the rightward direction. Again, if we find any queen, that means it is not safe. So we are returning false. Similarly, we are doing it for the lower right diagonal, upper left diagonal, lower left diagonal again, and the upper right diagonal, and in the end the normal upwards and leftward diagonals. If in any of the case we found any of the queen, we will just be returning from there false itself, and if all of these 8 conditions are right, then we will be simply returning true. That means it is safe to put your queen here. Here means at particular row comma column. So this is what this is safe function is. So let us again move to the original, like the main function, solve function. So if it is safe, we'll be placing the queen at this particular row comma call, and then we will be recursively traversing for next queen to be placed. When we will be like coming back from the recursion, we will just try to find some other solution as well. So we will again unplace this queen. Unplacing means we are putting a dot here, and then we'll try out some different configuration. So it will keep on happening, and in the end this solve function gets over, and we will get our all the configuration stored in our answer, and we'll be just returning the answer as a final output. So I hope you understand this part. So this was about the problem. So thank you.